Video number 9 plus. Images and reality. Hello everyone. In this video I take the opportunity of showing in which spirit I am working on this channel. I apologize in advance to any scientific listeners for whom what I am about to say is probably a bit too obvious. Point 1. The role and danger of images in science. When we want to communicate the results of scientific research to a large audience, it is generally excluded to enter technical details even more than in professional conferences where we are already often led to simplify certain things. In the absence of the precise language accessible to all, we therefore sometimes use images which help to clarify what we are talking about, but some of these images can give rise to misunderstandings if we consider them as a faithful representation of reality, where they rather have a symbolic value. In order that you understand what I mean, I will give a whole number of significant examples, the moral of the story being that we must not confuse reality with the convenient representations that are made of it for clarity of the presentation. Point 2. The representation of astronomical objects. You are often shown the solar system with its 9 planets, now 8, colored in such a way that accustomed persons can identify them immediately, but in fact, it is impossible to represent this system in a single drawing if we want to respect size and distance scales for the following reasons. First, the diameter of the Sun is about 100 times that of the Earth, and that of Jupiter about 10 times. Second, if we represent the Sun by a sphere having the size of a soccer ball, the Earth has the size of a grain of rice, located about 30 meters from our Sun. Jupiter is a marble located 150 meters away, and Neptune becomes a pea located almost a kilometer away from the soccer ball. It is obviously even worse if we want to include in the same drawing the star closest to us, Alpha Centauri. If the ball Sun is in Paris, Alpha Centauri becomes a slightly overinflated basketball located 10,000 kilometers away from Paris, for example in Tokyo, Seoul, or San Francisco. Professional astronomers constantly have in mind this order of magnitude that are impossible to represent on a drawing. When you are not a professional, it is difficult to realize the magnitude of what is commonly referred to as astronomical distances. Just realize that to go and check visually if Alpha Centauri is really a ball of fire comparable to the Sun, by traveling at the speed of 40,000 kilometers per hour, the escape speed, you would need 1 billion hours, or more than 100,000 years. The fastest human-launched space object so far could make the trip in just under 10,000 years. Point 3. The curvature of space-time. You have probably all seen the little artistic drawing where space-time is represented as a net stretched downwards by the presence of a massive object. It is then suggested that any object in the vicinity will fall into the well dug by the mass. But they forgot to tell you that in space there is no up or down. This depiction is therefore slightly biased, since it uses your visual integration of Earth's vertical gravity to make you believe that you understand the idea of space-time curvature, a relativistic formulation of gravity. When is the time of this drawing, since the space-time already integrates the time? From which configuration do we inform? What is around the net meant to represent the entire space-time? Of course, the experts in the field make calculations and do not need such naive representations to build their theories. But if you wanted to believe relativity because of the drawing, then you must realize that real science is not based, fortunately, on such simplistic representation. Point 4. Is gravity a force? Someone told me that gravity isn't a force because you don't feel it. This is a pure nonsense. All forces are not just simple arrows with an origin and end, as in physics elementary books where the arrow, actually, often represents the resultant of a large number of elementary forces adding up as geometrical vectors. In the case of weight, it is each of our atoms that undergoes an elementary force, including those which are inside our organism. These forces have a resultant which applies to our center of mass. Each of them is imperceptible, but in the long run, they can deform our body, causing wrinkles and organ collapse. Their existence, whatever name is given to them, is beyond doubt. Gravity may be warping the universe, assuming this sentence makes sense, but for sure it is warping us. And the time variable here reminds us of its existence for those who would doubt it and would like to make it dependent on space. Point 5. Giant fossils. You were shown, when you were a child, pretty dinosaurs with colors, scales, claws, etc. But all the artist's drawings presented to you are the result of scientific deductions made from a few bones by comparison with our current reptiles. There is absolutely no certitude that the dinosaurs were really as shown in the drawings. You have also surely seen fossil dragonflies, like in the image I am showing to you. In fact, all we have is a trace in the rock, the result of a natural molding, the insect having been digested by bacteria, and only the best professionals are able to deduce from this a likely representation of the original insect. Again, in comparison with current insects. The gigantism of fossil insects is one of the unsolved questions, as well as that of plants from the so-called Carboniferous period. They must have been really huge to bequeath us so much coal. But do we really have the proof? Again, all what we have is a molding. We may talk about this again later.